Hello, everyone. I'm Al Harsh. I am the Regional Director for Everest K2 here on the East Coast of the US. I'm going to be presenting today with Ryan Estrada, and helping me out will be Dakota and Johan as we go through this program. So I just wanted to say hello, and we're going to get right to the presentation. So what we're going to go through in this program is basically give you an idea how to identify all the products on the roof before you do a D-Dome project. We'll walk you through the steps of the installation itself. And then I'm going to pass this off to Ryan, who's going to go through some basics of the report you get when you use our online tool, as well as go through some keys on the legend that gives you important information to make sure that you're placing all the products in the right spot on the install itself. And if we have a chance, we'll go through a video, and I would just ask if you guys have any questions, you can type them in the questions section, and we're going to get to them at the end, because in most cases we usually answer the question before we get there. So just a little background on Everest K2. Right now we have about 10 gigawatts of our product in installation. These are our locations around the world. We are a global company. This is, we started back in 2004, and Dome actually came about in 2018. So you're seeing the latest version of this product. We also handle solutions for other roof surfaces. So if you're looking at another project that doesn't involve Dome, just give our website a look, and you can see what other applications that we have. So one of the key things at Everest, we don't just do third-party engineer testing, which everyone should do. We do our own in-house testing, and we have to adhere to European standards. So we like to think that, well, we don't just like to think, we know our products meet a higher standard than most other materials that are made in the industry for the same purpose. So just a little heads up when going onto our website. It's just going to show you here how to navigate our site and get to the actual information. You see the little lines up in the left-hand corner when you click on our site. If you click on that, go to products. Then from products, you pick the product you want. Then you can scroll down to downloads, and we have all the engineering and download documents there for you to upload to your own computer. And I think Ryan's going to go through this as well as a recap at the end. So this is the Dome product itself, just showing a basic install with a little translucency there so you can get an idea of what it looks like when it's installed. The reason someone wants to use our Dome product is basically two-part. One, we can fit more power density in the same space as a single system on the roof. And two, we do it with a much lower ballast count than most single-pitched systems. You'll hear me use two types of nomenclature in this presentation, and one is dual direction, the other is single pitch. So a lot of people call east-west dual direction now instead of east-west, and single pitch used to be called south-facing, because you're never really facing east-west, and you're never really facing just south when you're installing these systems. So this part here is the peak of the system, and it's just pointing out some of the areas where you have for wire management when you install it. But this is the top piece known as the peak for identification. And this is just showing wire management in an actual install setup there of your options. So the options for wire management are entirely up to the crew installing. Each crew I know has their own methodology of doing wire management, so we have quite a few options that you can take advantage of. This is known as the base piece here. So a peak and a base both go onto the same pad or installation. The next piece you want to know is the corner strut, and the corner strut has two sections of note. One is a tab, the other is the slotted graduated bolt hole here. The reason this hole is curved into the product is so that you can make minor adjustments for each different module size. So we can fit a variety of different module sizes with our dome product. And that little graduated hole allows you just to adjust that corner strut to take advantage of all the modules that you might want to install from a regular fixed position. For once you put the product in, you have a lot of adjustment there to work with. This is showing the ballast location between the peaks. So the ballast porters are the next part after the corner struts, and this is just showing the location between the peaks for them. You can also install them onto the corner struts as well. So our system can be installed with 3 different options. You can either go fully ballasted, fully attached, or a hybrid between attached and ballasted. And what happens is, even though we have a really low ballast count, if you run into a project where the headroom on your engineering for the building is kind of low, or a low number that you're trying to meet the building's requirement, we've been able to get that most of the time just with ballast. But if it gets tight and you need to fit you need to put less ballast on your array, just add a couple attachments, and then we can do a hybrid system within that. Our tool actually calculates this automatically, so it makes it really simple to adjust your ballast needs to whatever they want within the tool itself. These are little spacer pads, and I'm going to jump to video just real quick here to show you something. This is a standard pad that goes underneath either a peak or the base piece. These spacer pads are generally used, if you've ever done a commercial project before, you know that there's pitch breaks in the roof. And that pitch break allows just water flow on the roof from one side to the other so it can drain. And usually, as you're putting your array out, I'll just get this a little more centric here. As you're putting your array out, these pads might wind up, you have to place them kind of next to a pitch break or a drain where the surface of the roof is not exactly even. These little pads go in as just like a Lego would, and it just allows you to adjust the height of the system and keep the system level on the roof without having to shim it with anything else underneath there. So this just shows the basic layout put in. This is minus the corner struts and porters in this shot. Just showing basic of the module clamps, which, I will go over the clamps as well, because it's a common question. It's usually the one nuanced thing, let's say, with our product. So these clamps were designed with the installer in mind so that they can pick up the clamp and one-handed place it into the product with a glove on, and the clamp stays in place. So one of the tricks we like the installers to do is place all of the clamps into the peaks and the base part before you put them on top of the pads. This will eliminate a lot of the bending over on the job that you normally have to do. And anytime you can work standing up, it's just going to be less fatiguing for your employees, and the job can get done much faster. As far as install time, a common question that we normally get is, well, how long will it take to install your product compared to what I'm installing now? And in general, our product has about 1/3 or 30% less ballast weight than a standard system. To give you an example, one of the jobs that I did, we came in at, I believe, 1,100 blocks compared to 1,300 blocks of our competitors. So that's another 200 blocks to put in. Each block is about 26 pounds. So you can imagine if your crew doesn't have to put in an extra 200 blocks on the job and move that much weight, not once, but about 3 times, because normally when you're installing the ballast on the roof, your crane is there, it's lifting up your pallets of block. You can't just take a pallet full of block and place it on the roof, obviously, anywhere, because the roof was not designed to hold that kind of point load in one area. So normally blocks are lifted up on the roof. Your team is taking the blocks off of the pallets. They're putting it in different areas on the roof. Then you install them, then you have to move the blocks later on to another section. If you don't have to move 200 blocks another 2 times, that's literally like 600 blocks you're not moving in comparison to another product. Okay, so the jig. You want to make a jig for the product so you can space your pads on the roof. And I'll show you that as I walk through the install guide in a slide or two here. But this is showing a jig made out of a piece of aluminum, and we use L feet on the end just to space it. The jig is used so that your module can wind up 50-50 on your base piece and your peak piece back here. So your module is shared on each part. This lowers your part count on the project. So what I suggest, instead of using the piece of aluminum, if you just cut a standard piece of PVC pipe or PVC conduit and run a string through it, you can throw your pads on the ground. If they land upside down, you can kind of use one of those skateboard king flips to flip it over just by putting your foot on the corner there. Tap the pad into the approximate position in your foot when you line it up, and then you place the PVC stick in between your pads and just tap them over with your foot. It's going to eliminate a lot of bending over during the project and just make it easier for lining up the pads on the system. So we're showing here with the jigs, you'd need one jig for the length between peak to peak, and then you'd need another jig that's basically between peak to base. And the reason for that is this is the length side of the module, this is the width side of the module. And again, just cutting your jig so that you know your module measurement from the peak piece. And I'll go back to the video, the thing again, just so it's a little easier to see. Mine didn't come up. Hold on one second. All right, people can see you, even though I can't see myself. The module is going to end halfway on the top of this peak in this section, and it's going to go down till it's hitting this section of the base. So measure that space on one of them with your pad set, and if they're set correctly, then you just measure from pad to pad. So on the side of that, you'd measure from this side of the pad to this side of the pad on the one side, and from a peak going from the width of the module, you'd measure from this part of the pad to this part of the pad on the base piece. So you know you have it set. One thing that I didn't mention, we're going through this in a webinar series, but we also offer on-site training. As long as we have enough advance notice, we can set up for a technician, or even myself. I come to the jobs most of the time to do the dome training. Just having someone on site as a company rep, we can walk you through some basics of the install that make everything easy for the installers. I should say a lot easier than just watching a video and trying to do it yourself. And if that's just not possible, we can always do a virtual training, or I've had installers just FaceTime me from the job site so that I can look at what they're doing and make some suggestions or correct the situation there, because each job is unique and different, and sometimes some obstacles come up that we just didn't know about, and we can come up with a way to correct them for you on the job site. Also too, Ryan does the online training as a one-on-one virtually, so we can set up on Teams or Zoom or whatever platform works best for you, and do a one-on-one training of walking through the tool as well. It's just easier having someone to actually talk to and go through it. We want to make your job easier, so just let us know any way we can help out on that regard. So back to after the jig. So you got your jigs cut, you're laying out your pads first. So pads are the first thing to go in, and your pads are laid out with the spacing using the jig. Then we suggest you put the module clamps into the peaks and the bases before you go down each row and stick them on top of the pads themselves. And again, this installation guide that we're showing here is available on our website, and you can take your time and roll through it yourself and read all the captions if you'd like to. So here's another important part. Before you start your layout and put your peaks and pads in, you're just going to snap 2 chalk lines in a basic L configuration. And the thing to remember here is that all of your bases, you always start with your bases first. Your bases are your first row. Then your next row is peaks, then your bases again. So it's bases, peaks, bases, peaks, bases, peaks, and it just continues across the entire array that you're putting in. One point I'd like to make here, all modules need to be installed in pairs. This is a dual direction system, and the way our ballast is much lower on our system is because the modules themselves create a baffle for the wind on each side. So if you don't have a module on the other side of a module pair, so this is one module pair on the right here, this is another module pair, and so on, you can't leave out this module or this module. They both have to be there in a pair in order for your ballast calculations to be correct. So all the systems are designed in that module pair. I can't stress this enough, just because it's quite dangerous to not have proper ballasting on any solar project, not just one of ours. So the corner struts going on to the peak and the base. I'm just going to show this. I'm going to go back to video here, which I don't know why no one can see. People can see you, it says. Okay. Oh, you've hidden webcams. Just Dakota or Johan, I'm having a little challenge with my webcam here. I'm not sure if people are seeing it or they're not. Are you allowed to chime in so I can hear you?
Yep, we can see you.
Yeah, it's on.
Great.
You can just keep it on until
Okay.
Ryan goes.
Well, if I scratch my nose, I don't want everyone seeing. So, all right. So on the peak itself, you'll notice on the peak there's two tabs sticking up. Okay. Those tabs have two purposes. One, on a corner strut, you're going to notice the corner strut has two slots. This first slot is for your wider modules. Okay. The second slot is for shorter modules. So I believe it's if you're doing a 60 or a 72 cell, the inside slot or the closer slot would be for a 60 cell. This would be more for a 72 cell. It just gives you that extra distance when you're putting it in the peak. So your difference distance between your peak and your base is greater by using these slots. So again, 60 cell here, 72 cell here. When you're putting your porters on the peaks, porters can go in two sections. Just going to put the peak down for a second. Porters can go either on the peak on top of the tabs coming out of the peak, or the porters are installed on top of the tabs of a corner strut. Those are the two areas a porter goes. It either goes on the peak or it goes on the corner strut. And those porter locations are going to be parallel to each other. So these are just L feet, but it represents what the porters look like when they're sitting on top of the peak or on the corner strut. So if you have your porters on top of your corner strut, they need to face each other. And I always like to do this. The way to know that your porters are going in correctly, you just put your fingers out like this, okay? That's how your porters need to go in so that your ballast can sit on this section down here. So on the corner strut, your ballast is sitting more lengthwise, and on the peaks, the ballast is sitting widthwise, because on the peaks, if you were looking at it, they would be like this, okay? So a common mistake that often gets made, and I get a phone call for it, is the peak goes on here like this on top of the corner strut, and then they put the ballast porter on the corner strut, and then on this side of the peak, and then the ballast doesn't fit in between this space and this space over here. So porters on the peak, the ballast goes in between those on the peak. Ballast porters on the corner strut, the ballast only goes between the porters on the corner strut. It's probably the most common mistake made on site, aside from someone putting it in instead of like this, they do it like that. So if your porters look like that, that's the wrong way. Okay.
Hey, Al, we had a related question. I think it's good to just bring up now that somebody asked. They said, wind is obviously higher at the corners. Are there any extra ballast or clips for the corners?
That's a great question. So the corner strut is there to give you rigidity in the A-frame side of the system. So if I can go back, let's see for a second. Here we go. So if you notice on the A-frame side of the system, this area is open here, but in the front, very front edge of the array and the very back end of the array, there's only about a 2-inch space between that module and the roof itself. So there's really no uplift over here, but there's quite a bit more on the edges of the array. So the corner struts are there to lower that ballast in that area. And as Ryan will show you in the report, the difference between the ballast on the edges of an array and the middle of the array are quite different, but the tool calculates all of that for you. But the corner strut is there to lower that ballast in regard to the installation itself. Were there any other questions on that, Johan?
No, that was the only related one. And again, I just want to reiterate, Q&A, we'll do a big question and answer at the end. So type in your questions at in the little question box there. I'll be reviewing them if they're related to the exact topic that Al's going over, or Ryan. But otherwise, we'll wait till the end and we'll do a big Q&A to go over that. And to get your NAPCEP credit, you do have to stay till the very end anyway. So gotta stay for that Q&A. Go ahead, Al. Sorry to interrupt.
No worries. Thank you, Johan. So this is, again, just discussing what I showed you in the actual model here of the placement. These are the ballast blocks in between the porters on the corner strut itself. And these are the ballast blocks placed just on the peak. So just remember, when you're putting ballast blocks in, they're either going in between the peaks or in between the corner struts. They can go in both places at the same time, but separately. If anyone has a question about that, please feel free to ask after here, but that's what we know. These are just some options for the optimizer mount, and I have one on here. It basically just keyways into our little slot system underneath the peak. I suggest where your optimizers are going, or your microinverter mounts, put these on first on your peaks, and then when you go down your row, after your pads are set, after you laid your L out and you set your pads with your spacer, you're just putting your peak on, and when your peaks are in there, they should already have the clamps on them. And your optimizer mounts, again, it's just, you don't have to keep bending over, putting them down. You put them down once, your clamps are in there, the optimizer in there. It definitely saves a lot of time in the pre-setup of doing that. And wire management, again, just some options. You can, standard clips that go on there. We have those in our Everest catalog of parts. They are available. So whatever your wire management option choice is, just let us know, and we have something that works with the style of wire management you like to do. The ground lug. One interesting thing about this is in a 50 by 50 array, you only need one ground lug because the ground is integrated through the entire array. So this does cut down on a lot of copper on your install and labor, because you only have to do one home run basically from each separate array back to your ground source, but you only need one lug per separate array. And the minimum array, again, is 2 modules. You cannot do a single module. You must have at least one module pair. So if you had an array of 4 and an array of 2, then you'd need one ground lug for the 4 and one ground lug for the 2, just as a simple example on there. So here's some actual installs of the product placed in service. And one common thing we get, it's like, ooh, if I have to put in 2 modules and I can't leave one out, am I not losing space on the roof where I could have put more equipment? And in theory, I can see how that could sound correct, but it's actually not. The amount of space you gain by not having the wasted space on the inter-row spacing of the modules like you do on a single pitch system, because usually the ballast is sitting in between these areas. With ours, the ballast is tucked under the module itself. You get about 30% more room to put equipment on there. And like I said, on average, the difference between a single pitch in our system is about 30% more power density with about 30% less ballast weight. One thing that I didn't go over is on the pads themselves. These pads are made out of a recycled rubber material, and they do work with every known roofing type today, be it Carlisle, EPDM, rolled rubber. There is no adverse reaction between our pad and the roof material itself. However, the question of whether you need a slip sheet to go underneath this pad, between the pad and the roof surface, is entirely up to the roofing company that holds the warranty on that roof. They will dictate whether you need to use a slip sheet or not. It is not a question of whether our pads are compatible with the roof. It's a question of whether that roof company, that's responsible for the warranty on that roof says you need a slip sheet or not on that roof. So you definitely want to check that out with that company before you start your installation, because you don't want to have to go back later on and put slip sheets under there. One unique thing too, just a quick note on our pad, it is designed so when thermal changes happen and microseismic activities such as cars driving down a road past a building cause the array to just vibrate a little bit through the resonant frequency passing through the building, our system is designed so that the equipment can move on top of the pad. There is a little space here, and this allows for less microfracturing to happen to modules over the life of a system. So when you install a system with the Dome product, it takes into account that expansion and contraction that happens with aluminum and that slight adjustment of the system moving on top of that pad. It's not going to have the friction of the pads moving on the roof. It's all going to happen on top of the pad itself. So it's one unique feature, and we are certified to PV2 now, where most other companies are not, where we can move with that micro seismic activity and the thermal expansion with our product. Let's see, on the design tool, Ryan will take over in a second. I'll pass it off to Dakota, let her know when to change it. The tool is available in 15 languages. If there's someone on here where we don't have it in the language that you'd like it to be in, just please let us know. We're happy to adjust it and add another language to it. It's a work in progress, and we continually update our tool all the time as we either update products or update to meet the languages of the areas we're moving into.
Yeah, in fact, we do all these webinars too in Spanish too. So if anybody speaks Spanish and you're wondering about the Spanish versions of these webinars, we do have an office in Guadalajara, and that whole team does their own set of webinars based on their market. So if you're in Mexico, definitely sign up for those.
Yeah. Let's see. I'm just trying to think. I'll let Brian take it in a second. The only thing I didn't mention was on the clamps themselves, the torque values on there. We are a German company, so you must use German torque. So you got to make sure the clamps are good and tight on there. Pity laughter is exception here, but seriously, don't over tighten the clamps. The clamps on the mids, you're talking 12 pounds. On the end clamps, it's 10 pounds. Just over torquing them is more damaging than under torquing them. So, I know everyone's generally installing using an impact gun. Just make sure that your gun is not overdriving the clamp. It only takes 12 pounds to hold it in. It's not much on that torque gun to get it in there. So it's just one other important point I wanted to bring up. I'm going to pass it over to Ryan. So Dakota, if you can hand this off to Ryan, thank you. I'll still be on here and join you at the end. Thank you.
Yeah, and just while Ryan's getting set up, on that point that, that Al made is, a lot of guys, they're not going to pull out the torque wrench and actually do every single bolt. Some guys do, which that is the right way to do it. If you're using a torque wrench that it's calibrated for that PSF, for that 13 foot-pounds or 10, whatever it is. One thing I do, I used to install Al's on the roof a lot. One thing that's really helpful if you don't have the time or you don't want to pull out that actual torque wrench is you can calibrate your gun, a drill gun with the clutch setting, and play with one bolt and see with the torque spec how close you can get your gun to it. And once you do, you can use the drill on all those bolts. It's much faster, and you are not over torquing it, because you could crush the glass in the module if you really hit it too hard. I've seen people do that with all different clamps. It just pinches the glass, and it could cause some big damage. So I do plan on doing some videos on tips like that and others. So you can check out our base camp where we have all our training videos and whatnot. So it looks like Ryan's set up. Again, throw in your questions if you got them, and we'll do a Q&A at the end. But I'll let Ryan take over here. Go ahead, Ryan.
Thanks, Johan. Thanks, Al. Hi, everyone. Thanks for joining us. I'm Ryan with technical sales support here at Everest, and I mainly can work with your design team directly to translate your CAD 2D layout or your helioscope or whatever it be, translate that into BASON, and eventually want to, provide one-on-one training for your design team. And so, I use this tool almost daily. So if you want a training, please reach out to us, and I'd be happy to set that up. And we can do a similar type of screen share webinar. We can just walk through the project. So with our base tool, we have some separate recorded webinars on our website in the video section. But today I'm just going to jump into the output, the PDF report that gets spit out by our online tool, which is free, by the way. You just need an email to sign up. So I'm just going to run through this report, what you get from it and what you're going to need to bring onto the roof for the actual install. So you guys can all see this page here. The first couple pages is just some building information, building parameters, your wind and snow loads. And you can move down to, this is just an example, an overview with your basic roof dimensions there. And so it gets a little more granular as you go down. Zoom in a little bit here. You're going to want to pay attention to this legend. Most importantly, these orange lines are the corner struts that Al was explaining earlier for extra reinforcement. I think there was a question about higher wind loads on the edges of the array, on the corners. And so our tool automatically puts the corner struts here on these corner modules, and wherever it calculates that extra strength is needed. And so a lot of times people think they run out of corner struts because they put them on every single pair, but you only need them on the corners here. So that's a common question that comes up. So make sure to pay attention to this. And then more importantly, on the next page is your actual ballast plan. So if you look up at the legend here, the numbers in green represent the number of ballast blocks you'll need, and the numbers in red are anchors. And then the module pairs, each module pair is numbered in orange. So you have module pair 1, starting from the bottom left, module pair 2, 3, 4, and so on. And so we'll just look at this bottom left pair, module pair 1. You'll see in green 4, so that means 4 ballast blocks and 0 anchors, 0 in red here. And you'll notice all these red numbers are 0. This is a fully ballasted system. On that note, as Al was mentioned, our tool has the ability to limit the PSF. So say the structural engineer who gives you the stamp on the building says, okay, this roof can only handle a maximum of 8 pounds per square foot anywhere, maximum point load. So our tool has the ability, you can actually set that limit. You just type it in and it will replace ballast blocks with anchors, roof attachments, anchors in place of ballast. And that it'll automatically populate where you need anchors in place of ballast to hit that specific roof PSF. And it does it all automatically. So it's a pretty powerful tool. But this system here is fully ballasted.
Ryan, I want to bring up one point there. Can you just expand that a little bit on the bottom where the modules are?
Yep.
Great. So one key thing to note is you can fit up to 11 ballast blocks under our array between the peaks and the corner struts with the porters. I've never seen a system go that high. You know, usually like 4 in the corners is a high number. But what you'll notice on this, in the center of the array, if you look at module pair 19 and module pair 18, you'll notice there's a green 0 on for both of them. There's no ballast blocks required there, and that's because the load of the wind uplift is shared within the entire array. So while you might have ballast blocks on the ends a little higher, lower in the center, you might have 0 in the center of that array. So when we talked about, you know, using 30% less ballast block, this is an example. I don't think there's a single pitch system out there that has anywhere where you have 0 blocks or even just 2 blocks on that system. So that's it, Ryan. Go ahead.
Yeah. Yep. And you'll see this entire row here there's no ballast blocks or anything. It's all sharing the load with the surrounding modules. And then again, at the corners, you see your higher ballast count where there's higher wind loads in the corners. And then that ballast is distributed. It's all interconnected, so they share that same load, to Al's point. Yeah, and so that's why we're able to get such low pounds per square foot.
You know, and what you were saying before too on the corner strut legend, probably the most common thing at the job site is we'll get a call and someone will go, "Hey, you didn't send us enough corner struts." And I say, "Well, how many is the job supposed to have?" And they go, "Well, we don't know." I says, "Well, do you have the legend there?" And they go, "No." So we email it to them. I mean, as long as you give us access to it, we can send you that, and it calls it out here. You can see exactly how many you need. If you have more than what it's showing in this diagram, then you obviously ran short for a certain reason. So it's one of the most common things for a new installer is just putting too many corner struts in when they don't need as many. So that's all I wanted to mention there, Ryan.
Yeah, it seems a little, it's not very intuitive when you first, it just seems like instinctually people want to put a corner strut, on every pair, but if you only need them where they're labeled here. And then just moving through the rest of the report, some structural information, your dead loads, your PSF. This one has an average PSF of 4 and a maximum of 6.8, probably somewhere on the corners.
Yeah, usually on a single pitch, you're looking at 5 to 7 on something like that.
Mm-hmm. Yeah, and then some more structural information just for PE review, some deadweight information, and then your bill of materials. You can generate this and send it off to your distributor to get your material. For this report, I would definitely print this page out, the ballast plan, and probably the image showing the corner struts. Definitely print these 2 pages. I would probably make 2 or 3 copies and bring them up with you onto the roof, because you're going to be constantly referring back to this one to see the number of blocks and anchors per pair. So you'll want to print out 2 or 3 copies, maybe put them in a plastic sheet or laminate them so they don't get wet, but definitely have these on you, because you'll find that you'll be on the roof and you're going to be asking, "Hey, who's got that? Who's got that report?" So yeah, make some extra copies. And there's another important document that you're going to want to bring onto the roof. But this has, diagram and a legend, but it's just 1 page. So there's a more in-depth ballast guide with some examples of where to put the porters and the ballast blocks. So if you go to our homepage, the little sandwich menu on the top left, it's under products, D-Dome Railless² System. And then if you scroll down to the tabs, go over to the download section, and then you have your assembly instructions, some technical documents. At the very bottom, there's a roof ballast guide. And this is going to be extremely valuable for your install team. So again, it gives you a legend. All of your components are here represented with these colored shapes. And we'll just go into an example. Here. So this would be a hybrid ballast blocks and anchor. So the 11 ballast blocks, that's like an extreme example for somewhere with some crazy 180 mile-an-hour winds or something like that. But you'll rarely see 11 ballast blocks here. This is just for example's sake to show the max capacity of our system. So we'll look at this bottom right module pair in detail. Module pair number 216 calls for 11 blocks and 1 anchor. So to get 11 blocks in there, you can run 2 porters down the middle along the peak. As Al mentioned, they're going to go in portrait, lengthwise, I guess. We'll call it portrait. And then on your corner struts, they will go in landscape. So you can do 7 in landscape, 4 in portrait. So you'll have a total of 1, 2, 3, 4 porters, 11 blocks. And then here's another porter with the anchor attachment. The red one notes the anchor. And just a note on that, if it's a hybrid system, ballast and anchored, you can't attach an anchor where there are already ballast blocks. So the anchor needs its own porter. So you need two porters to support ballast blocks, but when you have an anchor, you just need to run 1 in the tabs and have that independent on its own porter. So another example, the anchors only. Say, small array, they just want a hard attach, 1 anchor per pair, no blocks. Again, here, you would just put run 1 porter and then put the anchor there. And just a note on anchor placement, there's 6 places where you can put the anchor, or 6 spots for the porter to run. But we'd recommend putting the anchor towards the outside of the array just to resist that wind uplift that's coming from the edge of the array. The system's flexible, so if there's a roof obstruction there, you can put it somewhere else. You can put it on this side, you can put it over here. But just in general, as a rule of thumb, it's best to put all your support closest to the edge. And that's just for the edge modules. And then here's another example. This is probably more something that you're going to see more often, 2 to 5 ballast blocks. It's pretty low profile system, doesn't get as much wind uplift with those as a single pitch system. So looking at this bottom left pair here, module pair 1, 3 blocks, 0 anchors. So you can either run 2 down the middle and run 3 long ways, or you can put them on the corner struts. In this case, since it's an edge module, you want to put the ballast on the left side along the corner struts towards the edge of the array. Another thing to note are ballast porters, or the ballast blocks sit in the porters and they're raised above the roof. So when there's moisture, rain, it won't collect in like a ballast tray, and so you don't go through these freezing and thawing cycles, which can just destroy the ballast blocks. So they're sitting up, elevated off the roof. So that's another advantage for the longevity of the system. And that's about it. So I would definitely print out this roof ballast guide. It's under the downloads tab on our website. And then don't forget for the PDF report, these 2 pages that show the ballast plan and your corner strut placement.
Very good, Ryan.
With that,
Ryan,
I think we can go in.
Yeah, I wanted to add, along with having those sheets on site are just really important. I would suggest print out your bill of materials too. Check it against what's delivered. The first thing that you want to look at, if you think you're short on materials, you look at your porter and your corner strut guide. and make sure that correlates first before you wonder if you are short. What I've seen some install teams do is just have the leads on the team, whoever's putting the corner struts in. Usually it's one or two people on the team that are tasked with just installing the corner struts and the porters on the array. They can just take a picture with their phone of that, and then as they're walking down, they can just hold the phone in their hand and kind of see where they go and place them into those spots too. So, you know, everyone can have access to that information on there.
Yeah, that's a good idea.
So that's about all we have for today. I want to thank everyone for joining this webinar. Again, you know, if you need any assistance on site, don't be afraid to call us directly. You're not going to get a phone tree. You're going to get an actual person who can either walk you through the tool and laying out a system that you might have a challenge with, or just learning the tool itself. Or if you need assistance on site, we can offer it virtually with FaceTime, or even just a phone call. We could diagnose something sometimes with a picture. Or if you need someone to actually come on site, give us advance notice. We'd be happy to show up there, walk your team through a system, do the first install with you. On behalf of Dakota, Johan, Ryan, and myself.
We do have some questions. I just wanted to make sure we didn't skip questions. Yeah. So thank you guys for presenting that information. And so another question came in for the wind at the corner. And so I think it's the same question of wanting more weight and ballast at the corner. So the tool that Ryan is talking about is called Base. It's our online design tool, and that builds in the calculations based on your region. So if you put in the address, it is going to account for all the wind of that building and where it's located on that building. And the engineering is built in for our system with all the testing that we've done, and the weight and the engineering calcs. It's all built in. So you don't need additional ballast. If you do, based on that area, it will calculate it and it will tell you where you need additional ballast anywhere, or anchors if it's seismic. So it's all built in. So I highly recommend using our tool because it's specific for this product. And again, Ryan can help your designers get familiarized with this product, the Base tool, and it's free. I highly suggest going on, playing with it yourself. It's pretty intuitive. And then if you have some questions, Ryan or some of our inside sales team can guide you through it, our technical sales team. And also we are doing webinars on the Base tool as well. So it's really site specific. So, but the corner struts, again, are only for the corner, and the ballast blocks, because it's a dual tilt system, you are kind of naturally ballasting the system with the weight of the modules on each side, and then it means that you have less ballast blocks in the entire system. So that's that less ballast that ballast blocks needed that Al talked about earlier, as opposed to other competing systems that are probably a single tilt or a south facing system. So again, I mean, obviously you are going to need ballast, and it depends on the jurisdiction, the region. So if you go into the Base tool, it will calculate that for you, and we can help additionally too.
I'd like to add something to that, Johan, and it's a very important point here. And I hate to use this expression, but it's true. It's garbage in, garbage out. The tool is basically a calculator. It's a very advanced calculator, but it will only calculate the information that you're putting into it. If you do not put in the correct site parameters, the tool will calculate your ballast on the site parameters that went into it. That's all the tool knows in that sense. So please make sure you're doing on-site field evaluation and measurements, that your building height is correct, your parapet height is correct, the zip code that you're in is, the actual zip code where the building is located, because that has to do with the wind charts that are available. But making sure you have that building height, the parapet height, and the zip code correct on there is going to allow the tool to calculate those numbers for ballast and the corner struts and everything else correctly on your system. Should you need to make adjustments to that, because let's say the engineer says, well, you know, you're coming in at 4 pounds per square foot. I can only come in at 3.5. Then you can put those numbers into that tool and make that adjustment. But please make sure the numbers you're putting in there are the actual numbers required for that project, and the tool will calculate for that for all your ballast needs and corner struts on.
Great. Thanks for that, Al. Some other questions and a part of a comment too. Oh, this is great to see somebody who's used the product. Someone said, I installed one of these about 4 or 5 years ago and it's working amazing. My question is, since this is an east-west facing system, where can I find production data for this versus south-facing systems?
Okay, so Aurora does have it. You can set up for dual direction and go through Aurora and get your modeling. So I guess when your sales team, you know, it's important because your sales team wants to know what are they going to tell the customer with regard to what the system is actually going to produce on the roof. So I know Aurora is set up for that. I'm sure there's other software programs. Ryan, do you know of what else they use aside from Aurora? I think Eagle View, does that allow for the same type of production value?
I've seen production on charts on the helioscope for east-west.
Okay. Yep.
But probably, yeah, I've seen probably helioscope in Aurora.
Yeah. The one thing that gets people is they think just because you're facing dual direction and it's normally kind of close to east or west, that your production is that much lower than a single pitch system. But from most of the systems that we've designed, single pitch is never really going in exactly solar south. So, you know, solar south is basically a couple of degrees declination off of magnetic south, and the geometry of the roof, you know, let's say this is the roof itself and it's on its site, the building might be askew on the lot and anything off of solar south. But if you're putting your array in, you're going to match the geometry of your roof. You're not going to take your array and kind of put it in this way. You're going to put it in matching the shape of the roof. So it is dictating the direction those modules are actually sitting on there. And with the production itself, it is different in how a dual direction makes its power, because your power curve duration is more of a curve like this compared to single pitch, what looks like this. So we're finding that inverters are never driven past their sweet spot. They're always running in the sweet spot with a dual direction system compared to east-west, where you start off, you run into the highest peak and the inverters can clip, and then it goes into the lower section. Longevity of inverters is a bit better, and that power curve is longer during the whole part of the day. So any other questions, Johan?
Johan, you're muted.
Okay. Can you see any there, Dakota?
Sorry. There you go. Sorry, I just took over the screen. Can you guys see my slide there? I have a couple slides on the difference. I know it's not, we don't have anything that calculates the exact system that you're designing, but you know, Tyler, who's one of our engineers, our design engineer, he actually had some really good slides that I pulled out. You know, this is just showing the difference between south facing versus, you know, we had one in Germany that we brought over to the US, but the D-Dome just did much better as far as, you know, your ROI and the cost and whatnot. But that inter-row shading is just wasted space. And granted, we're not going to lie, sometimes a south-facing system might be a better way to go. But the dual tilt system does have a lot of benefits. So obviously you got south-facing system here. This is just a little example of a you know, a case scenario. And let me move my menus blocking the screen. There we go. So 7 rows, 5 modules, and we go through. Oh, I don't know why this is an old deck that we did. Oh, sorry. There we go. 35 modules, 305 watts times 35. So you got, you know, they're just doing the difference between the spacing and the loss factor. So this is just a very basic comparison. It's not like exactly going to happen every time on your system. Is this like a pretty standard 30-foot by 50-foot roof with these 35 modules, kind of a smaller, light commercial system? But we break it down and it comes down to about a 43% increase. So
it's
around 40%. Very low
you're
square
fitting
footage
that
on
many
that.
more modules in the same spot or same roof real estate, let's say, as a south-facing system. So, it's obvious if you had a single pitch system facing solar south and you had a dual direction facing east and west of the same size, the production would be higher on a single pitch south-facing system than a dual direction of the same size by a few percent. But when you take into account that you can fit about 35% more in that same space, that production irradiance factor capacity is a negligible point compared to the amount of actual wattage you can sell the customer in comparison. So that's it.
And there
I
is
think
something to say
we're on
about
time.
also. Oh, go ahead, Al. Sorry. Go ahead.
No, how are we on time, Johan? I don't want to keep everyone past there.
We should have like 5 minutes. We're pretty
Okay.
good, actually. Yeah. I don't see many other questions coming in, so it's good that we're just kind of diving deep into some of this,
Yeah.
I'll look at some of the questions, but I did want to say, one of the things is to keep in mind is you got to do the math. I would highly recommend designing a system the way you do, and then going into base and designing this system and compare them. Some job sites might be better for one or the other. And we're not going to just try to sell you the system because we want to make the money. We want you to install a system that works best for your project. And sometimes dual facing works best. And there is something to say about less ballast blocks being carried to the roof and to the job. So by having a module on the other side, not only are you maximizing the space, but you're creating less ballast blocks that have to be carried. And there's something to say about the labor involved in that, taking it all up there. Obviously they're cheap, but it's a lot less labor and time on the roof. So that's definitely one thing to keep in mind. I'm looking at the questions.
Well,
go ahead.
I'm thinking if you're getting another 2, 3, or maybe 4 pallets of block more, that's time that a crane has to sit there and hold that pallet of block above the roof. So I know here, in the East Coast, I was up in Mass. Geez, I think it was $500 for a half a day for a small crane that we were operating with. So you're easily running into a half a day more, for using a crane on site with that much more ballast block. With another
Right.
system.
Actually, we have. You don't even have to take it from us. Somebody who mentioned that they've installed the system 4 or 5 years ago commented again and said, "And we're not paying this guy." They said, "Thanks. System is keeping up with most of my south-facing systems. I appreciate it."
Wow.
So there you go. There's somebody that installed the system and has done south-facing systems. I don't see a name tag, but thank you for mentioning that. It's really good to hear back from people who are doing these things. All right. So that's about it. I did want to point out that we do a lot more. I know everybody is, different cities have different regulations with, sheltering in place, and it's kind of scary times, but we're doing our best to train remotely. And like Al and Ryan said, that we can help you guys out. If you want to do a private session like this, we can just schedule something, a webinar with your team. We can unmute you guys so you can all speak, and we can do it privately for your company based on whatever products you're using with Everest. And we're coming out with a lot more new products as well. So I work myself with the products team. So does Al to give his input that comes from you guys. We get voice of customer meetings. That's actually a requirement with new products. Before we release it, we have to talk to customers using the products. What do you want to change? What is working? What is not working? And it all goes into our product builds. So with that being said, we are releasing the new 44X for residential, and we are moving those products to a single tool system, so you can just use one 13mm socket for the entire system. So if you haven't used our cross rail for residential, that works in dual rail and shared rail. And these mids and end clamps that Al showed, some of these are the same components that lend to that system as well. So that MK3 that goes in that works in our same railed channel for residential or some light commercial if you're doing that with our 80 or ground mount. And you can see behind me, I'm at my house and I have a little setup here, and we do demonstrations all the time. I'll bring my camera up close for customers all the time and show them how the parts work. If you're new to that system, we'll back you up and show you. And Al's not just sitting behind a desk. He's on the roof all the time. I have a background in installation myself, more on the residential side. So we understand what you're faced with, and Ryan's done a great job at doing design. He has actually an engineering background, so he understands the importance of proper engineering, and he's designing those systems with customers and designers. So definitely use our resources. Go to our website, check us out.
Hold on, Johan. On the end of our presentation, we have my contact information and Ryan's. Can we pull up that part of the for the presentation again? Because I would like everyone to have my direct number and Ryan's number.
Yes. Here we go. So this is our outside sales team. You can still see my screen, I imagine, yeah? It's just delayed a little bit. Give it a second, sorry. There it is. This one, right?
Yeah. So, yep. So that's my direct cell number on there and my email. I want everyone to walk away knowing one thing. One of the most important things for us at Everest is that we don't want anyone to be on the roof and not be able to get a question answered when they're in the middle of the install. We know that's one of your most important times, is delivering to your customer what you promised them. If you are on the roof and you have a question on an install and need assistance, please do not hesitate to text or call my cell phone number and put in these words: I am on an installation and I have a question. That will get my fastest reply to you. I will get back to you as soon as I can. The only time where I won't get back to you that quick is if I'm on a flight or something like that, which shouldn't happen, right now. But even if I am, if I see that text, I will forward it over to someone in our company who can address you right up on the roof. And we generally travel with parts with us all the time, so it's easy for us to kind of walk through stuff and show you how stuff goes together if you need to, right on the roof site. So if you're on the site, have a question, make sure you use that wording in your request, and it will get our fastest reply. Again, I thank you all for joining us, and we look forward to serving you in the future with our product line.
All right, thanks, guys. So if you want this presentation, we'll send it out to everybody, and it will be recorded as well. And go to our website, check out our YouTube channel. You can check out Base there and all our product information. And we do have more webinars coming up on different topics, so be sure to check that and sign up on our newsletter as well. So thank you guys for joining. We'll see you next time. Have a good day.
Thank you. Be well. Stay safe.